Most people think CICD is just a pipeline that magically runs in the background. You push code, then lights turn green and something goes live. But the truth is far more interesting. Under the surface, an entire automated system of networks, events, and isolation springs into action. Today, you're going to see how CICD actually works, not from a tool's perspective, but from the system's point of view. Once you understand this, CICD stops being a black box and starts making sense. It all begins with a single command. You type git push and hit enter. In that moment, your code stops being files on a laptop and becomes packets on a network. Those packets are wrapped in application-level protocols, encrypted for security, split into pieces, and launched across the internet. They travel through routers, switches, fiber cables, and wireless signals, sometimes taking different paths, before being reassembled perfectly at the destination. The code arrives, but more importantly, it creates an event. An event is just a message that says, something changed. That message moves across the network to an automated control system designed to react instantly. Before anything runs, identity is verified, rules are checked, and branches are validated. Only then does CICD move forward. A build environment is created. Not a long-running server and not a machine you log into. A temporary, isolated workspace that exists for one job, turning source code into a deployable artifact. The source is pulled in securely, and the transformation begins. Each build step runs in isolation using operating system boundaries. It can't see other processes and can't interfere with the host. CPU, memory, and execution time are limited to keep the build environment controlled and secure. Each instruction is executed in isolation and produces a snapshot of the file system. These snapshots are stacked one on top of another, forming layers. Together, these layers become a container image. Each layer is given a unique fingerprint, compressed, encrypted, and sent over the network. On the receiving side, the container registry does not rely on names or tags. It identifies everything by cryptographic hashes. If a layer already exists, it is reused instead of being stored again. Nothing is overwritten, and identical data is stored only once. Once the image is fully stored, the build environment is destroyed, and only the final artifact survives. At this point, CICD moves from building to delivery. The control plane detects the new image and creates a new version of the workload. Containers are then scheduled automatically. Each container runs inside a secure sandbox that isolates it from the host system. Containers that are not working properly do not receive traffic. If more users arrive, the system automatically starts more containers. During all of this, the system keeps watching everything. Logs record what happens, and metrics show how well the application is performing. So here's the real mental model of CICD. A code change becomes packets. Packets trigger an event. The event creates a build, and the build produces an immutable artifact. The artifact becomes a running container, and finally scaling happens automatically.